Hi, Algebra 2. This is Mrs. Langford. We're going to go over some notes on graphing rational functions. So it's concept 38. We're not going to do the whole packet of the 38 notes, just part of them. Okay, so the first thing is at the top of your notes page, it says the parent function for rational functions with a linear numerator and a linear denominator is f of x equals 1 or some number value divided by x. So the graph at the right is the graph of this function, which we talked about in the concept 37 notes, and it is called a hyperbola. And remember that a hyperbola has branches, and so together that makes the entire graph of this function. So we're going to skip this exploration and just get right to the notes. So you can skip that next part and just go to example 1. But look at that core concept that I have for you. So again, this is some of its repeat information, but just to go over, so the parent function of a simple rational function is f of x equals 1 over x. And the graph is called a hyperbola, and that consists of two parts called branches. The domain and the range of just this simple parent rational function are all non-zero real numbers. So basically, x cannot equal 0 and y will not equal 0. And we talked about, again, in those concept 37 notes, that a rational function has both a vertical asymptote and a horizontal asymptote. And those asymptotes are where the domain and the range limitations are. So the vertical asymptote is the x-axis, which has the equation, the y-axis, which has the equation x equals 0, and the horizontal asymptote is the x-axis that has the equation y equals 0. So now let's look at example 1. So we're going to graph a rational function in the form y equals some number over x. So we're going to graph 4 over x. So right away, we know that our domain x cannot equal 0 because that would be undefined. And then y will not equal 0 because there's no number we can divide 4 by. That will just make it go away, become nothing. So we'll put that in our table, and then we are going to plug in values for x to the left and the right of our vertical asymptote. So notice that I made a note of that in the middle of our table. I put 0 because that's our vertical asymptote, and then just draw a line through. And then I put 3 x values that are to the left and 3 that are to the right, and I plugged them into our equation and then got the y values that we'll graph. So you're going to draw your xy axis and label your scale, and then plot your points. And remember that those points are going to create the two branches. Our vertical asymptote will be our x and our y axis. And then if we look back at the problem, it says compare the graph with the parent function, 1 over x. Well, our a value does the same as it's done before in other functions. So if it's greater than 1, we're going to have a vertical stretch. Remember, as I'm giving these notes, please pause the video so you can catch up and write down everything. And try things on your own as well. So now we're going to, of course, translate these simple rational functions. So look in the core concept and see now the equation with the a, h, and k values. So the h affects the x or the input, and the k is out at the end of the math of the function. So to graph it, I like these steps. Step 1, you're going to locate and draw the asymptotes. So thinking in this form, it's easy to locate the asymptotes. Your vertical asymptote, x, will equal your h value, and your horizontal, y, will equal your k value. Then you're going to plot points to the left and the right of that vertical asymptote. Then you're going to draw your two branches of the hyperbola so they pass through the points and they approach but do not touch or cross the asymptotes. So let's look at our example 2. We're going to graph negative 4 over x plus 2 minus 1. So my h value, remember it's the opposite of what we see, it's negative 2, and my k value is negative 1. So right away I know where my vertical and my horizontal asymptotes are. So my vertical asymptote is the h value, and my horizontal asymptote is the k value. So then I'm going to plot points to the left and the right of that vertical asymptote, -2. So I plug in -3, 4, and 5, and -1, 0, and 1, and I get the points. Draw your x and y axis in scale, and then go ahead and sketch in those asymptotes. We didn't do that the first, or I didn't the first graph, but that's the best way, because then you have just your places, or kind of your limitations, that you know where to draw your branches. Then plot your points and draw your branches. All right. Now before we leave this problem, let's look at the equation and anticipate all of the transformations that we should see. So notice our a value, which is 4, is actually -4. So we have a reflection. Rather than those branches being in quadrants, the 1 and 3 area, they are in 2 and 4. We've been shifted to the left, see our h value there, and then 1 down. Now domain and range, you can look at the asymptotes to help you out. And so our domain is that x cannot equal 2, and then our range is that y will not equal -1, our h and our k value. All right, let's look at this next graph. So 3 over x minus 2. So our h value is 0 and our k is -2. So that means our vertical asymptote will be at x equals 0, so right on the y-axis, and then our horizontal will be the line y equals -2. Let's go ahead and just name our domain and range. So that means, since those are our asymptotes, that's what our x value cannot equal. So x cannot equal 0, and our y value cannot equal, or won't equal, -2. So let's plug in points to the left and the right of our vertical asymptote, which is at 0. I like to do 3 points because then you can really kind of get the feel of where the branches are going. So draw your x and y axis, label a scale, and then sketch in your asymptotes. Now plot your points and then create those branches. And then we've got a whole picture of that graph. All right, we're going to stop here, and we'll do the rest of the graphing notes tomorrow. So now you can work on your assignment.